Alright, so a curve has equation given by this mixture of a quadratic and reciprocal equation. Find the x-coordinate of the point on the curve at which dy over dx equals 0. Okay, so they kind of tell us what to do. They want us to firstly get to dy over dx, so that's the first thing we should do. Now to get this equation to dy dx, we need to rewrite this into index notation, yeah? So my advice is, because you're dividing the whole top by 2 over root x, we can partition a fraction. We can say, alright, let y equal, well, 4x squared over 2 root x plus, and then do 9 over that, 9 over 2 root x. And then we should just try and simplify this as we go. So doing over here now, we have y equals, well, 4 over 2 is just 2. X squared over root x. Well, if we recall from question 1, I think it was, root x is the same as x to the half, yeah? And well, when you're dividing x terms with the same base, you subtract the powers. So it's going to be 2 take away a half, which is 3 over 2 or 1.5. So just to make it easy, I'm just going to write x to the power of 1.5. Now the next part, plus, well, 9 over 2 is 4.5. And then root x against x to the half. To bring it upwards would be x to the negative half, or 0.5, minus 0.5. So now we got this sorted out, we can go ahead and differentiate this into the dy over dx form. So therefore we say dy over dx, well, to differentiate, the rule is that you drop the power, so it'll be 2 times 1.5, which is 3, and you subtract the power by 1, which is 0.5 or half. Likewise, do the same thing here, so it'll be 4.5 times minus half. Well, what I always do is just put that in the calculator so you don't get a mistake, and you should get minus 9 over 4x, and then subtract the power by 1, you get minus 3 over 2. Again, it's up to you, decimal form, fraction form, it's all good. Now that you've sorted this out, they said find the x-coordinate of the point at which this equation is equal to 0. So then we can say, alright, therefore all of this should be equal to 0. Now just go ahead and rewrite and make x a subject. So let's go ahead and pull 9 over 4x to the minus 3 over 2 to the other side. So we're going to get 3x to the power of a half equals 9 over 4x to the negative 3 over 2. Okay, now a quick rule of indices, yeah? My personal advice is just literally divide the entire term across. Put all the x's on one side, numbers on the other. So what I would do, I'm going to throw ahead, divide x and negative 3 over 2 across, and divide this 3 to the other side. So moving this to the left, we're going to get, and moving 3 to the right, we should now get x to the half over x to the negative 3 over 2 equals 9 over 4 all over 3. Now, this is easy. Now we're pretty much done here. In your calculator, just write, when you're dividing x terms, you subtract the powers, yeah? So it'd be half take away minus 3 over 2. Well, that should give you x to the 2. So half take away, that gives you a 2. And 9 over 4 divided by 3 should give us 3 over 4. And what, we're done here. We're actually almost done. Now they want us to find x coordinates, so well, square root the result, and you should get x equals plus minus root 3 over 2. And just checking which x coordinate they want, it said early in the beginning that x is greater than 0. It's positive. In other words, we want the positive solution. So therefore, the real solution is just x equals root 3 over 2. Yeah, and that's it, guys. That's this one done. Alright, number 10. So curve C1 has equation y equals fx, yeah? Now, A, sketch this curve showing the coordinates of any point where the curve touches or crosses the coordinate axes. Alright, so as it says, we just draw our xy axes, and we just need to know where this cubic curve, so we know it's cubic because you got a linear term here and you got 2 linear terms here because it's squared. And when you got 3 of them, it makes a cubic. Or if you expand it, well, you'll get a cubic term. Now, to know what the points of intersection are, so when you sketch something like this, we always set this to 0. We ask ourselves, well, what are the solutions of x? Well, in the first case, you got 4x minus 3 is 0. This automatically means that x equals, well, 3 over 4. You just rearrange it. As for the second term, because it hits at x equals 5 twice, then on the curve it's going to bounce off the x-axis. So if it hits once, it goes through. If it hits twice, it bounces. So we've got a repeat route here. Now to plot this, well, since we know what the coordinates are, hits at 3 over 4, which we can say is there, and hits at 5, which we can just imagine is there. We also need to know where it hits on the y-axis now. Now, a quick way to do this is to just literally multiply these constant terms, yeah? So if I was to expand this slightly, showing 3 brackets, like 4x minus 3 times x minus 5, and then another x minus 5, and of course y equals. If I just focus on the last 3 constants, yeah? If we do minus 3 times minus 5 times another minus 5, it's going to give you, well, minus 75 actually. So this means it's going to hit somewhere at minus 75. And now if we draw the cubic curve, and we should know the cubic curve always looks a bit like that, yeah? If it's positive, it starts at the bottom, shoots up. This means it's going to cut through here, hit at 3 over 4, and then instead of going through 5, because it hits that twice, you can imagine it as bouncing off it. And that's it. This is pretty much all you need to show. So you hit the x coordinates and you hit the y coordinate at minus 75. Okay, I think that's it then, yeah? As for part B, it says hence or otherwise, find the values of x for which this function at the point, so the same function at the point, instead of x is a quarter x, equals 0. Alright, all that's literally saying to you now. So since you know what the function of x is, well, we just replace all these x's with that value. We could just replace the x solutions here with a quarter x. So for instance, it says 3/4, right? Instead of x equals 3/4, we can say a quarter x. Well, I'm going to rewrite this as x over 4, guys, yeah? X over 4 now equals 3/4, and x over 4 now equals 5. Well, this is straightforward. Just times 4 across, then x here would equal 3, times 4 across, and now x equals 20. I think that's just the I part done. Now for II, it says find the value of the constant p such that the curve with equation y equals the function plus p. Okay, so what this means now, if it's plus p, it means that the curve now shifts upwards or downwards, depending if it's positive or negative, yeah? And passes through the origin. Okay, alright, so it tells us already. So in fact, this curve actually passes through the origin, so it's the same curve now. If this entire curve shifts upwards by p, this means this curve, instead of hitting at minus 75, it hits at 0 now, right? That means all of this, if it's instead of 3/4, it's gone up by, well, it's gone up by 75, isn't it? So that means it hits at 3/4, 75 here. And this 5 also hits at, well, 75 too. And then shifts up. Now, find the value of the constant p. Well, clearly p in this case must be 75, because the only way we can hit the origin if it went up to 70, went up by 75 points across the y-axis. Alright, so that's all good so far. Anyway, guys, so far, if you guys got any doubts or questions, always drop a comment and let me know. So, but let's have a look at the second bit. A second curve C2 has equation y equals gx. Alright, so just recap here. The previous one was called fx, yeah? Where gx equals fx, f at the point x plus 1. So instead of fx, you're going to replace x with x plus 1, yeah? And those two are equal now. And for part C, it wants us to find in its simplest form gx. Alright, let's make this clear. So all they want us to do is just literally equate gx with fx plus 1. Or in this case, gx is fx plus 1. So let's go ahead and replace all these x's with x plus 1, guys, yeah? So this means that therefore gx is going to equal, well, at x plus 1, we're going to have 4 times x plus 1. So what I would do, instead of writing x plus 1, put in a little bracket, yeah? Like that. Copy the rest of the equation. Times, instead of x, again, it'll be x plus 1 minus 5 all squared. And just to make life a bit easier, I'm going to make it twice, yeah? Just put 2 brackets. X plus 1 minus 5. Alright, so I can see what they're kind of doing here now, yeah? It's going to be kind of long. Okay, it says find in simplest form, and you may leave your answer in a factorized form. Okay, sweet. So we actually don't have to expand it. So we just have to tidy up the inside. Right, so what that means then, yeah? So looking at this one, and instead you can keep it as a squared bracket then. Let's keep it as a squared bracket, guys. Alright, so on the first one, I'm going to expand this nicely, yeah? So it'll be 4x plus 4 minus 3. And doing it quickly, well, 4 take away 3 is just a 1. So that part is done. Second bit, x plus 1 take away 5. Well, that's just x plus 1 because there's nothing before it. Take away 5. And put a power 2. And well, 1 take away 5 is minus 4. Yeah, minus 4. So just put minus 4 there, squared. And yeah, that's it actually. And part 2, hence or otherwise find the y-intercept of this curve. Alright, that's not bad. That's literally like we did for part A, yeah, where we found minus 75, where we just multiplied the 3 last terms, yeah. So again, we do the same thing, and just to make it clear, I'll put this as 2 separate brackets. And then to get the last intercept, it's going to be plus 1 times minus 4 times minus 4, which means, so for part 2, we say that the y-intercept of C2 is just 16. That's it, guys. And here we go, guys, the final question. So what do we have here? So now it says that a curve has equation y equals fx where f to the second derivative, so this is the second derivative, equals this function here. Alright, so instead of the usual way, they're starting off with literally d2y over dx squared. Okay, so that's what we're beginning with here. Now it tells us that the point P lies on this curve. Given that the first derivative x, so this is also known as the gradient expression, equals minus 4, so in other words the gradient is minus 4 at point P. Find the equation of the normal at P, writing your answer in that form. Okay, so since we know what the gradient at P is minus 4, therefore the equation of the normal, in other words the normal of that gradient, is the perpendicular gradient, guys, yeah? So if the gradient is minus 4, then the new gradient for the normal is the negative reciprocal, which is plus quarter. Now, just remember, yeah, all you do is flip the sign and make it 1 over, and then you have it. Now, to do this one, since we got most of the equation, we can say therefore, just writing in this form, we have y equals a quarter x plus c. And now, since we know that we're interested in the equation at point P, we just plug in a p coordinate to find c. So we say, all right, at p, which is 4 minus 50, we plug in x for 4 and y for minus 50. We're going to have minus 50 equals a quarter times 4, which is 1, and then plus c. And well, solving for c is quite easy. Subtract 1 and c is therefore minus 51. And that's it, guys. And then we say therefore, for part A, our equation of the normal is just y equals a quarter x. Instead of c is minus 51. Yeah, that's one part done. And now finally, find fx. Alright, so this is just completely different, yeah? Looks to me that we have to integrate this equation twice, yeah? So, alright, let's have a go, yeah? So first things first, always write this one in index form, yeah? So I'm going to start from here. So f prime prime x equals, well, okay, so let's break this apart actually. You got root x cubed. Well, if it's a square root, it's a power of a half, so this is just x to the 3 over 2. Bring it back on the top line, it's just going to be 6x to the negative 3 over 2. And then plus x. Now, if we integrate this once to go to the first derivative, so if we're going back upwards, we're going to integrate, yeah? Well, integrate means you're going to add this by 1, so it'll be minus 1 over 2, so it'll be 6x to the power of minus 1 over 2, and divided by itself, which is minus 1 over 2. Same thing here, yeah? Plus, this is just a power of 1, guys, yeah? So integrate this, so it'll be x squared over itself, 2. Now, because we're integrating, you always write plus c. And before we integrate one more time, what I would personally recommend is firstly simplify this equation and find the value c. Trust me, it's going to make it a lot easier. So if you do that, we say, okay, just put this in your calculator. So 6 over minus a half, that's going to give you minus 12x to the negative half. Again, and you can just leave as is actually. But I'll write plus half x squared plus c. You know what? Keeping this form actually is a lot nicer. So this is your f prime x. Now we have some information to get c, yeah? In the beginning, it tells us that given that f prime x equals minus 4 at p, so in other words, when this part is minus 4, we know at p x is 4. So replace that in. We can say therefore minus 4 equals minus 12 times 4 to the power negative half plus, you know, I actually don't like that form. So it'll be 4 squared over 2 plus c. Oof. So again, you just have to make c the subject here. Go work all this out and then just rearrange it. And when you do that, and I actually need to do it right now, and c here becomes minus 6. Okay, that's not too bad. Now just updating this equation, so I'm just gonna do it over here. So all of this becomes minus 6. Okay. Now once again you're gonna integrate this, guys, and try and get fx. So start from here, yeah. So this is gonna be one of your main results. We can say therefore fx, guys, is just the integral of this part. Now integrating one more time, again you raise the power to plus half, so it'll be minus 12x to the power of plus half over half, and then plus, instead of x squared, it will be x cubed over, what, 2 times 3 is 6, and then plus, oh yeah, this is minus 6, and then you get minus 6x. So if it's just a constant, you stick an x in front, and then you write 1 over plus c. I'm not going to use plus c again, so let's call it plus k. And then therefore, okay, you could simplify this, which is probably better. So you're going to get, well, minus 12 over a half is minus 24x power of a half, plus, yep, just copy the rest. X cubed over 6 minus 6x plus k. And that's fx. Okay, now, all right, so now you want to find that value of k, right? So again, we just have to find any coordinate, and yep, we can still use the same one. We can still use p, which is 4 minus 50, because we actually have, well, values for x and y. And just remember, guys, yeah, when you go back to fx, fx is the same as y, okay? So we can say at, what's the p coordinate? 4 minus 50. When x is 4, y is minus 50. So just plug in all of this into that equation, so replacing all the x values here with 4, and replacing this y value here with minus 50, and then just solving for k. Well, k should actually somehow become 34 over 3. If you're not sure how that works, you know, just drop me a comment, yeah? And then we say, all right, therefore, guys, fx is going to equal, again, copy the whole thing, minus 24x to the half plus x cubed over 6 minus 6x plus 34 over 3. And that's it.